Hello everyone, this lesson is for solving inequalities. So just a review, when you have to graph an inequality, if you have just the less than or the greater than symbols, then you're going to graph at that number, but graph an open circle showing that that number is not included, and then you shade the side of that line that represents all possible solutions. So if x is greater than -2, you've got your open circle at -2 and the shading showing all of the solutions that are greater than that -2. You're going to have a closed circle if this equal sign is included. So with a similar example, x is less than or equal to 2, you'd have a filled in circle on 2 showing that that number 2 is included with that equal sign. And you want all of the possible answers that are less than 2 will represent a solution. So 1 is less than 2, 0 is less than 2. So you shade to the left for that line. For solving inequalities, you would solve an inequality the exact same way you would an equation. You're going to use transformations, so adding or subtracting terms to isolate that variable. So just think of the inequality symbol as being where an equal sign would be. So as an equation, x plus 2 equals 7, you'd use inverse operation. So instead of adding 2, you would subtract 2 on each side to keep it balanced. And 2 minus 2 cancels off. You're left with x. 7 minus 2, you have 5. So in this case, x is equal to 5. In this example over here where we have an inequality, you're going to solve it the same way. You're still going to subtract subtract 2 on each side. But instead of an equal sign, you're going to have that inequality. So x would be any number greater than 5. So let's look at a few examples. If I have 2x plus 3 is less than 9, think of this as an equation. You're working to get x by itself. So right now it's 2 times x plus 3. You want to work backwards. So the last step was adding 3, so you want to subtract 3 first to get this 2x term by itself. So 3 minus 3, those two cancel each other off, and you're left with a 2x by itself. And then 9 minus 3 is 6. So we have less than 6. Think of this now as 2 times x is less than 6. So instead of multiplying by 2, we would divide by 2. And these two cancel off, and you would be left with x is less than 3. So this would be your answer. X represents any value less than 3. So if you were to choose to check your answer, and if x has to be less than 3, if we choose 2, and we plug it into our inequality, so 2x plus 3 is less than 9. 2 is a number that's less than 3, so 2 times 2 plus 3 is less than 9. 4 plus 3 is less than 9, and 4 plus 3 is 7. 7 is less than 9, so it checked out. Another example, this one is m divided by 6 minus 2 is less than 2. So we're working backwards. We want to get our m terms by itself. So our first step, we want to add 2 on each side. You're working backwards. You're trying to get this term by itself. So on the same side of that inequality, we've got this minus 2. The opposite of subtracting 2 is to add 2. So these two cancel off, and you're left with m divided by 6 is less than 4. M divided by 6, the opposite of dividing by 6 is to multiply by 6. So if you multiply this side by 6 and multiply this side of your inequality by 6, 6 divided by 6 cancels off, and you're left with m is less than 24. So m has to be less than 24. And again, you can check your answer. Choose a number less than 24 to plug in to check it out. So if I say 18, 18 is less than 24. So 18 divided by 6 minus 2, that should work out to be less than 2. 18 divided by 6 is 3, minus 2 is less than 2, and 3 minus 2 is 1. 1 is less than 2, so that one checked out. Now, the important difference with solving inequalities is when you multiply or divide by a negative. If you are working through your solution and you ever come across where you have to multiply or divide by a negative number, you have to flip that inequality in your answer. So in this example, we had negative 3x is less than 12. So to solve, I would divide each side by a negative 3. Negative 3 divided by negative 3, we have x. 12 divided by negative 3, we have negative 4. But you have to flip that inequality when you divide or multiply by a negative number. So in this example, negative 4x is less than 24. If you divide by a negative 4 to get x by itself, negative 4 divided by negative 4 cancels out. You've got x. 24 divided by negative 4 is a negative 6, but since we divided by a negative number, I have to flip that inequality. And you can check your answer. So x is greater than negative 6. I can choose any number greater than negative 6. So if I choose negative 5 and I plug it into my original problem, negative 4 times negative 5 is less than 24. Negative 4 times negative 5 is 20. Is less than 24. That checked out. If you did not flip your inequality, so let's say you had your answer as x is less than negative 6. So if I choose any number less than negative 6, so let's say I choose negative 7. If I plug it in here, negative 4 times negative 7 is less than 24. Negative 4 times negative 7 is a positive 28. 28 is not less than 24, so it's not a solution. It did not work out. So make sure when you multiply or divide by a negative number, you flip that inequality so that you have a true correct solution. And a couple examples with the trickier problems. Just remember you're trying to work to get x by itself. So if you think of this one as being x plus 1 all divided by 3, the opposite of dividing by 3 for your last step would be to multiply by 3. So you have to multiply both sides by 3 so that this denominator cancels out. 3 times negative 5 is a negative 15, is greater than or equal to, and you're left with an x plus 1. Last step, subtract 1 so you get x by itself, and you have a negative 16 is greater than or equal to x. And this is actually the same answer if you wrote it as x is less than or equal to negative 16. These two are the same answer. Notice that this inequality is opening up to the negative 16 with our answer flip-flopped around. It's still opening up to that negative 16. So you can change the order. Just make sure your inequality is facing the right number. And one last example, if you have to use the distributive property with these, make sure, so 4n minus 6 times n plus 1 is greater than 12. Make sure you're multiplying through this as a negative 1 or a negative 6. So negative 6 times n, and think of it as a negative 6 times 1. So 4n, negative 6 times n is a minus 6n. Negative 6 times a positive 1 is a minus 6 is greater than 12. So if you've got that subtraction, think of it as a negative number so you have the right sign there. And then 4n minus 6n is a negative 2n minus 6 is greater than 12. We want our minus 2n by itself, so we want to add 6 because it's the opposite. So then we have a negative 2n is greater than 18. And the last step, we want to divide by a negative 2. Negative 2 divided by 2 is n. I divided by a negative, so I have to flip that inequality. And then 18 divided by a negative 2 is a negative 9. And then always get in the habit of checking your answer. If n has to be less than negative 9, check your answer by plugging in a number less than negative 9. So negative 10 is less than negative 9. So if I plug in negative 10 into my original problem, it should be greater than 12. So 4 times negative 10, we have a negative 40. Minus 6 times negative 10 plus 1 is a negative 9 is greater than 12. So then we have negative 40 minus 6 times a negative 9 is a negative 54. And then if you add the opposite, so add the opposite, you end up with negative 40 plus 54, and that comes out to be 14. And 14 is greater than 12, so it checked out.